I'm going to try something a bit out of my comfort zone today. I'm going to attempt to create the night rider lights in a PLC program. And that's going to be a bit of an experiment because I have little to no experience using ladder logic for programming a PLC. And the PLC I'm going to use is the Omron CP1L and the L14 DT1D in this case. And the reason I'm using this one is because it has an adjuster, an analog adjuster that sends a value from 0 to 255 to address 642, and I'm hoping that I can use this to change the speed of my night rider lights. But the main reason is because I don't have another PLC. So if we go online, put it in program mode, go to the memory, go to address, go to 642, put it in monitor mode, and then we can see the value. And if I turn the potentiometer, you can see that the value will change. Turn it all the way down, it will say 0, 0, and if I turn it all the way up, it will go to FF, because it's a hexadecimal value. Nope. So let's see if we can use that in a timer. I'm going to use input 0 because that's where I've mounted a little switch, and I'm going to need a timer. Let's see in our find instructions, timers and counters. We have a lot of different timers and counters, but I can open the help section. Timers and counters. So 100 milliseconds, BCD type. TIM-H is a 10 millisecond BCD type. We have a TIM-H-X, that's also 10 millisecond, but it's a binary. We have long timers, we have an 100 millisecond. I think I'm going to use the 10 milliseconds because the value runs from 0 to 255, so I can adjust it from 0 to 2.5 seconds, and I think that's enough. So I'm going to use the TIM-H-X, the binary type, because it's a hexadecimal, and binary is sort of the same in a PLC. So I'm going to use the HX. So a TIM-H-X instruction is not available for current PLC. Why? Okay. Timer H is available. Well, we'll just see what timer H does. And timer H will need a number, so 0001, and we'll use address 642 because that's where our value is, and is red. Why is it red? And it's not longer red. Why? I have no idea what I'm doing. Okay. Can I run this in a simulator? Yes, I can. And I'll turn the switch on. turn the switch off, but the value is 0 because it's run in a simulator. So we'll have to go online, I think. Transfer the program to our PLC. Transfer, yes, yes. Okay. Error. Is that maybe because it's a BCD type? What else do we have? Conversion instructions. Binary to BCD. Converts a binary word to BCD. Yep. Yeah, okay then. BCD. BCD. Address 642. I'll probably need to store it in some sort of a memory address, so I'll use the holding address 0. Why is it red? Everything I type is red. I'll just use an always on in this case. And the value for my timer needs to come from H0. Let's go online again. There's no error so far. Put it in run mode. It's a value of 255. What happens if I turn the potentiometer? And it seems to change. Okay, so there's no error. And if I flip the switch, that seems to be working. Nice. Okay, so a little bit of a detour, but we can use the analog adjuster. Let's delete this one, as since I'm always going to need this part, I'm going to put it in a different section, and I'm going to rename this converter and main program words are difficult. Program. God damn it. So my main program code will be nice and neat. My converter is in a different section. And this was standard when I started a new program, because the end line is also in a different section. So I have my converter here, store to address 0, holding address 0, and here we can start our main program. So let's start creating our program. I'm going to use input 0, where the switch is mounted, as a start signal, and we're going to use a timer 0001, and for testing I'm going to use a fixed value, because then I can run it in a simulator. So I'll just use 100 for 1 second delay. And let's see, timer 1. I think I'm going to use set and reset instead of just directly outputting it to a coil. Okay, so if I set my switch, the timer will run for 1 second, and then it sets output 0. Then I'm going to use output 0 to start the next timer. 002 hashtag 100 timer 2, and this one will set output 1, and it will reset output 0. Okay, let's see that in the simulation. Flip my switch. Yeah, this will remain on. So when I flip my switch, it will wait for 1 second, turn output 00 to on, then it waits another second, and then it sets output 01 to on and output 0 to off. So if I keep repeating this, I should be able to do this for all 5 outputs. So I think I can copy paste this. So this one is 01, timer number 3, timer 3, set 002 and reset 001. I copy, paste 2, 4, T4, and this is 4 because output 3 is the lower one on my PLC, so I need output 4 in this case. Reset number 2, copy paste, so this is number 4. Oh, output 5, T5, output 5, and reset number 4, copy, paste 5, timer 6, output 6, and reset output 5. Let's see, that's 1, that's 2, that's 3, that's 4, and that's 5. I think I have 1 too many. 1, 2, 3, 4, 5. Okay, I don't need this one. I only need to have a reset. I can move this, right? Okay. remove this. Right. Let's do a test run first. That's 1, 2. Oh, and then reset. It's a bit difficult to see in a simulation, so I'll just go online and transfer it to the PLC. Okay, let's see what happens when we flip the switch. Okay, that seems to work. Let's do another test, because I think if I set the switch again, see, it will just keep repeating the cycle. That's not good. So I need to find a different way to set the start signal. So instead of using the switch directly, I think I'm going to use another parameter, just like we did with the analog value. So the switch will set 100, I don't know. And then this one will be 100. So if I flip the switch now, it will set the value. Oh, I set it to 1. Oops. It needs to be 100. So if I flip the switch, it will set the value to 100. It will start the program, and it doesn't matter if I turn the switch on or off several times, it will just keep the value to set. Okay. So now that we made it go in one direction, we have to make it go in reverse as well. So here I'm resetting output 5, and I need to set output 4. Yes, it's a double, I know. But if I set output 4, this time I will start again, and it will go back to 5. So it will be switching between outputs 4 and 5. So I need to disable the other timers, and in order to do this, I'll probably need to insert a close contact with another parameter. But I think if I do that here, the on-off switch will be disabled, and it will behave like it did before we used the parameter here. So I think I'm going to eliminate this this one to disable the timers. So I'm going to insert my start button here. I will keep this one. And I think I'm going to make this a reset. I can't, why not? Reset H100, and this one needs to be a closed one, and I'm going to insert it here as well. And this one as well. This one is going in reverse, so this needs to be an open contact. So if I repeat this step, just copy paste it for now. No, I need to add something else here because this one needs to set H100 or do we need to add it here? I think I'll need to add it here. This one needs to set H100. This one needs to be deleted, and then I can copy these steps. So this one needs to be 04, timer 7, timer 7 needs to reset number 4 and needs to set number 2. And then we'll copy paste, and this one needs to be number 2, timer 8, timer 8, set number 2, no, reset number 2 and set number 1. And one more time. Number 1, timer 9, reset number 1 and set 100. And if I set 100, this timer starts again. So I think I'll need to reset this one back to 0, but I'm going to upload it first. I'm going to save it first, and then I'm going to upload it to see what happens. Okay, run mode. So let's flip the switch.
seems to work. That's number 1, 2, 3, 4, 5, 4, 3, 2, and back to 1. Okay.
Okay, so it will return back to the first position. That means that if I insert a set, no, I insert a reset again. It was reset, and then halfway through the H100 address gets set. So at the end I'll do the reset again, and it should go on forever. Still not sure what to do about the on-off switch, the start switch. I'll just leave it for now, and since it will go on forever, I will also set this one back to the analog input so we can adjust the speed. So we'll do that for all timers. Save the program, and then we can upload the program. And set it back to run mode, and then we can see if it will actually work.
Okay, let's flip the switch. Four, 3, 2, 1, and it will keep going. And if we slowly adjust the potentiometer, we can make it go faster. And we can make it go slower. Nice.
So that's it. We made night ladder lights for a PLC in Ladder Logic. I'm pretty sure it can be done much easier, but as I said in the beginning, I have 0 to no experience, and this is the way that I did it. If you know a faster way, please let me know in the comments.